Have you ever checked the reviews before buying something online? If you see that more than 50% of people gave it 5 stars, you're likely to buy it. That's statistics in action. Statistics isn't just about math problems, it's how we make decisions every day. From budgeting your family expenses to predicting if a project will succeed. But before we can make those big decisions, we have to turn a mess of numbers into a clear story. Today on STEMBridge, we're going to learn how to organize raw data into powerful tables and graphs. Making sense of messy data, frequency distribution explained. Raw data is also termed as the ungrouped data. It's the data which has not been arranged in a systematic order, either ascending or descending. Grouped data, on the other hand, is a tabular arrangement of data in which various items or values are arranged in some classes. Classes are also termed as groups, and the group data is termed as a frequency distribution. We have examples of ungrouped data like 10, 18, 38, 15, 30, 27, and so on. These are just numbers, they are scattered, and we haven't arranged them in any sort of order. Here, if you look at the example of group data, we have the first column, which is marks obtained, and the second column, number of students. We have the first category or the first class from 1 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50. So in total, we have 5 classes, 1, 2, 3, 4, and 5. And if you look at the number of students, here we have the number of students, how much marks they obtained. So the number of students that obtained marks from 1 to 10 are 4. The number of students that obtained marks from 11 to 20 are 12, and so on. And the total count of the number of students is 50. 4 added with 12 with 11, again with 11 and 12. So that is their total count. Now, what is the number of groups? The number of groups depends on the size of data. It is usually between and 5 it is usually between 5 and 15. If you look at this table right here, you will see that in the first column, we have marks obtained and we have 5 categories. This is the first category, the second, the third, the fourth, and the fifth. So that is the number of groups in this data. Now, what is class limit? We know that we have the first minimum value, which is 1, and the maximum value of the first class as 10. So our lower class limit is 1 while our upper class limit is 10. Same as for the second group, here our lower class limit will be 11 while our upper class limit will be 20. So basically, the group or a class is defined by two numbers, the smaller number, which is the lower class limit, and the larger number, which is the upper class limit. And I showed you the example from 1 to 10 and 11 to 20. Here, the minimum value is the lower class limit, while the greater value is the upper class limit. Now moving on to class boundaries. They are those numbers which do not belong in any specific category. If you look at this example of group data, you will notice that we have the lower class limit and the upper class limit. But what if we take the value which is between 10 and 11? So the value between 10 and 11 is 10.5. So 10.5, we can see that here we only have whole numbers. We do not have any decimal value or any float value. So that means that 10.5, the student that obtained 10.5 marks, he doesn't belong in any specific category. So what is this? This is a boundary. But as we know that we took the value of 10 and we added that with 0.5. So that is 10.5. So this will be our boundary, but it will be our upper class boundary. And if we take the minimum value, which is 1, we are going to subtract that with 0.5. So that is 0.5. So our minimum or our lower class boundary is 0.5, but our upper class boundary is 10.5. So we can create a new column or a new data, and then inside of that data, we can say 0.5 to 10.5. So we have introduced the boundaries, the class boundaries, the minimum class, lower class boundary, and the upper class or greater class boundary. Now we deducted 0.5 from the lower class limit and added 0.5 to the upper class limit. So that is how you get boundaries. So this is its adjustment factor 1 by 2. It is a fraction. It can be written as 0.5. So the lower limit to the upper limit. We subtract 0.5 from the lower limit, but we add 0.5 to the upper limit. Now let's move on to your textbook so you guys can understand it very easily. To understand the difference between class limits and class boundaries, look at the following table. Here we have the scores. They are known as the class intervals from 1 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50. So what will be their lower limits? It will be the minimum value. So that is 1, 11, 21, 31, and 41. What about their upper limits? That will be the greater value for each group or class, like 10, 20, 30, 40, and 50. Now we need to find their boundaries, which will be the lower class boundary and the upper class boundary. For the lower class boundary, we will subtract 1 with 0.5, so that leaves us with 0.5. Now we will subtract 11 with 0.5, that is 10.5, 21 with 0.5, so that is 20.5, and so on. But for upper boundaries, we will add 0.5 with a greater value. So we have 10 added with 0.5, that is 10.5, 20.5, 30.5, 40.5, and 50.5. So now we found their lower boundaries, their upper boundaries separately. But what if we want to make a group for that? So we can make a column which is titled class boundaries and then enlist the lower boundaries with the upper boundaries, like 0.5 with 10.5, 10.5 with 20.5, 20.5 with 30.5, and so on. So this is the difference between class limits and class boundaries as well as class intervals. Now, what is the size of class interval? The size of class interval is the difference of the lower limits and the upper limits of two consecutive classes. It is denoted by the symbol h. For example, we have 1 and 10, 11 and 20, 21 and 30. The size of their class interval will be 10. How can we find the class interval? If you look at the first group, if you take the lower limit of this group, which is 1, and you look at the second group and take the lower limit of that group as well, subtract both of them, you will get 10. As well as if you look at the third group, which is the third class, and the second class, subtract their minimum or lower limits, you will also get 10. So that is how you find the value of h or class intervals. Now moving on to class marks, they are also known as the mid values. It is the average of the lower and upper limits of boundaries of a class, and the class marks are denoted by x. So if you look at the class mark of the first group, which is 1 to 10, if you add the lower and upper limit, divide that by 2, that is 5.5. If you look at the second group, which is 11 to 20, add the upper and lower limit, divide that by 2, so you have 15.5. So these are the class marks. They are the average of lower and upper limits. Now you should note that the difference of class marks of two consecutive classes is equal to the size of class interval h, and the class boundaries can be derived from the class marks x and size of class interval h by using this formula. Okay, moving on to frequency. What is frequency? It is the number of repetitions of an individual value in an ungrouped data. That is frequency. So if you look at a group data, the number of values present in a group is called the frequency of the group. Looking at the first table, we know that the marks is from 1 to 10 and the students who obtained that many marks are 4. So that means there are 4 students whose obtained marks are between 1 and 10, both inclusive. Moving on to cumulative frequency. The sum of frequency of a class and the frequencies of all the preceding classes is called cumulative frequency. The construction of frequency distribution table. So now we are going to look on how we can construct a frequency distribution table or a grouped data. We can use two methods. First is the tally bar method and the second is the direct observation method. In the tally bar method, you will first decide how many groups will be made in the table, and then you can find the approximate size of the class interval the class interval is denoted by h. So if you want to find the approximate size, you need to subtract the larger value in the ungrouped data with the smallest value in the ungrouped data and divide that by n, where n is the approximate number of classes and h is the size of class interval. Then you need to draw a table and write the class limits in the first column according to the size of your class interval. And then you can choose the values from your ungrouped data one by one and simply draw the small tally marks. You can draw that in the second column against the respective group. If 5 or more than 5 values fall in a same group, then you will draw the fifth tally diagonally. This means that, for example, I have 4 students, so I can write 1, 2, 3, 4. And then the fifth tally mark, it can be written diagonally like this. So that is how you write tally marks. And in step number 5, you need to count the tally marks of each group and then you can write their number against the respective class. So that will be the column of frequencies and the column of tally marks. You can now find the sum of all frequencies and you can check that it must be equal to the number of values present in your data group. So the number of total items in your ungrouped data, let's suppose that is n, that should be equal to the sum of frequencies in group data. Now, if you look at the first example, the following are masses in pounds of 40 boys at a gym. So we know that we will make a frequency distribution table using an appropriate size of class interval by using the tally bar method. We will distribute this data in 5 classes. So we are going to check this data and find the largest value. We know that the largest value here is 176 and the smallest value here is 125. So we have 176 and 125 and we want to distribute our data into 5 classes. So we have XF, which is our greater value, XS, which is our smaller value, and the value of N. So we will now make a size of our class interval. We will again use the formula, which is XF minus XS divided by N. Now we will place our values here. So we get 10.2. Now we know that we are going to distribute our data in 5 classes. So we made up 5 classes. We labeled that as the masses in pounds. Now we are going to write their frequencies on how many people have their masses in pounds from 125 to 135. And then we can write their tally marks as we learned how to do in the above example. And then we can write the sum of all the frequencies. So that will be 40. 8 added with 13 added with 11, then 6 and 2, so that will be equal to 40. This is how you make a frequency distribution table using an appropriate size of class interval by the tally bar method. The second method is the direct observation method. In this method, the values of the ungrouped data are written in the second column of our table against the respective group of tally marks. That means that instead of the tally mark section, we will remove that and write our observation. The remaining process of construction of frequency table by the direct method is same as that of the tally bar method. So you will have the observation column and you can count how many observations you found of people that were from the masses in pounds 125 to 135. And then you can write their number. When ungrouped data are not arranged in any order, then it is better to use tally bar method. In the first example, the frequency table by the direct method can be constructed as follows. So here we have 5 classes or groups and we wrote their observations and then we can write their frequency in the next column. So the sum of all the frequencies will be equal to 40. Now, discrete frequency distribution. If our data is not in fractions and some values occur most often to constitute the whole data, then our data is called a discrete data. And there is no need of class boundaries as the size of class interval will be 1. Now, if you look at the example number 2, we have a cubical die that has been rolled 30 times and the number of dots on the front face recorded each time are as follows. We need to make a discrete frequency distribution. So we know that if we want to make a discrete frequency distribution, we will just separately write the numbers. So that means that each class, the size of each class interval will be 1. And we will also make a column of cumulative frequency, which I will show you how to find. So if you look at this ungrouped data, we have the values of 2, 6, 3, 1, and 5. So we can make a column which is labeled as the number of dots and write 1, 2, 3, 4, 5, and 6. And then we need to see how many times does these number of dots occur. Like we have the number of dots as 1. So how many times did 1 occur in this table? 1, 2, 3, and 4. So we can write the frequency as 4. And if we want to write the tally marks, then we can also do so by drawing simply vertical lines. If we had a frequency of 5, then what we could do was we could write the tally marks as 4, and then we could make a diagonal line above it. And to find the cumulative frequency, we just need to take the sum of frequency in the first table. So we have the first table, the sum of frequency will just be 4. But the cumulative frequency of the second class will be the frequency of the second class added with the frequency of the previous class. That means 4 will be added with 6. So that is 10. That is how you find the cumulative frequency. And here are the tally marks as shown. So the total number of frequencies which we have here is 30. So you just need to take the sum of all the frequencies. Okay, now we will learn how we can construct the histogram. Different types of charts and graphs are used to represent a data effectively. It becomes very easy to get a quick idea about the data and to analyze by means of graphs and charts. In a histogram, our data is represented by adjacent rectangles which have bases along the horizontal axis, and that is marked off by class boundaries, and the areas proportional to the class frequencies. If our class interval size is the same, then that means our heights of the rectangles will be proportional to the class frequencies as we learned in grade 8th. If our class interval size is unequal, then the heights of rectangles need to be adjusted. How can a histogram be constructed with unequal size of class intervals? If the size of class intervals or h is unequal, then to make areas of rectangles of a histogram proportional to their frequencies, the heights of the rectangles have to be adjusted. We know that in a histogram, the area of a rectangle is directly proportional to frequency. So instead of area, we can just write height into width or length into breadth is proportional to frequency. And if we just write height is directly proportional, so height will be directly proportional to frequency over width, but width is directly proportional to frequency over height. Thus, the height of the rectangle can be found by dividing our frequency by our width of class interval. This ratio, which is frequency over width being equal to h, is called the frequency density. To make a histogram with unequal sizes of class intervals, we plot our class boundaries on the x-axis, that is the horizontal line, and frequency densities on the y-axis, which is our vertical line. If you look here in example number 3, the heights in centimeter of 44 students of a school is given below, and we need to represent this data by a histogram. So the height we have given in centimeters. How many groups do we have? We have 1, 2, 3, 4, 5, and 6. So we have 6 classes or groups, and the number of students whose height is from 130 to 144 centimeter is 9, and so on. To represent this data by a histogram, we can write the first column as our height in centimeter with our classes. Then we need to write the frequency. We can write the frequency in tally marks or by direct observation. Then we will write the size of the class interval. Here the size of the class interval is 15. Why? Because if you subtract 145, which is the least class limit of the second group, with the least class limit of the first group, so you get 15. So that is how you find the size of your class interval. And to find the frequency density, if you add the size of class interval with your frequency, you will get your frequency density. And here the class boundaries, 130, which is the least class limit, it will be deducted 0.5. So that means we have 129.5. And 0.5 will be added to the greater class limit. which is 144.5, and so on you can do with the other columns. So our total frequency will be 44, and we can plot this by using a histogram. So we will first select a title. We have a histogram showing the heights of 44 students in a secondary school. So along the x-axis we have plotted the class boundaries, and along the y-axis we have the frequency densities. So we chose a suitable scale for 2 centimeter. It represents 15 centimeter on the horizontal axis. So then we plotted it for 129.5 centimeter. The frequency density will be 0.6. Then for 144.5 centimeter, our frequency distribution table will be 1.4. For 149.5, our frequency density will be 1.6, and for 154.5 it will also be 1.6. So this is how you plot a histogram. To conclude this lecture, I'll give you some questions which you need to solve, and then you can email me to find out the correct answer. The first MCQ: when data is organized into a table showing classes and the number of items falling into each class, then what is this arrangement called? Is it frequency polygon, raw data, group data, or cumulative frequency? In the second MCQ, for a class interval defined as 21 to 30 in a frequency distribution, what are the corresponding class boundaries? Is it 21.5 to 30.5, or 20.5 to 30.5, 20 to 31, or 21 to 30? Moving on to the third MCQ, what is the class mark or the midpoint for the class interval 136 to 146? Is it 141 or 136, or 10 or 146? Which graphical method uses adjacent rectangles to represent the frequency distribution of continuous data? Is that graphical method histogram, discrete frequency graph, tally bar chart, or frequency polygon? To construct a frequency polygon, line segments are used to join the midpoints of the tops of the bars in a histogram. What are these midpoints on the x-axis called? Frequencies, class boundaries, class marks, or class limits? If the frequencies for the first four classes in a distribution are 8, 14, 12, and 6, then what is the cumulative frequency of the third class? When creating a histogram with unequal class intervals, the height of each rectangle must be adjusted. What is this adjusted height representing frequency per unit of class interval called? Class mark, frequency density, relative frequency, or adjusted width? Given a data set with a smallest value of 125 and a largest value of 176, what is the approximate size of the class interval if you want to create 5 classes? 60.2, 51, 10.2, or 11? What is the primary purpose of using class boundaries instead of class limits when drawing a histogram? To ensure there are no gaps between the rectangles, to center the data more effectively, to simplify the calculation of frequencies, to make the y-axis scale more accurate. Moving on to the last MCQ, how is a frequency polygon graph typically closed so it starts and ends on the horizontal axis? The graph is left open and does not touch the horizontal axis. By dropping vertical lines from the first and last points to the x-axis, by connecting the first point to the origin, or by adding points for hypothetical classes with zero frequency at both ends. I hope you liked my video. Don't forget to like and subscribe for more ways to simplify this complex. I'll see you in the next one.